after all the formality, let's talk about what's the key concept of energy. Okay, so there's two key concepts. Concept number one, I'll say them and then I'll write them down. Concept number one is all objects have energy during its motion. Okay, you just need to accept two facts and then we'll understand how to calculate, understand why things move and how things move. Okay, fact number one, all objects have energy at different parts of its lifetime. Different part, when I say lifetime, it's motion. So if it goes from here, projectile motion, let's say, go from here to here throughout its lifetime, throughout its history, throughout its motion, more correctly, it's throughout its motion, just to be poetic, saying it's its lifetime. At every point, it has different amount of energies and different types of energies. Okay, all objects during each time, it has different types and different amount of energy. Fact number two is if you add up all the energies, it will be the same number. That's called the law of conservation of energy. So energy, in other words, you'll hear people say energy cannot be created or destroyed. It can only be transformed. Okay, it will turn from one type of energy to another type of energy throughout its lifetime. It doesn't have to be projectile motion, any motion, right? Projectile motion is one example. Yeah, throughout its lifetime, right? So but when at every point in time, if you add up the total amount of energy it has, it will be constant. Okay, so that's called the conservation of energy. With these two facts, so if you ask me why is these two facts, if you ask me why does objects have energy, I cannot answer that. If you ask me why is the concept, why is when you add them up it will never change, I cannot answer that. It's a law. What is a law? Like I said, sometimes it's mysterious, right? When people say it's a law of nature. Well, what is a law? But I've demystified it and say a law is an observation that repeats itself over and over again. We don't know why. Right? Now, there's a difference between historical laws and fundamental laws. And in some sense, all laws are going to be historical. What that means is a historical law is at that moment in history, when the law was written, there was no explanation. Okay, so you will learn a lot of laws in physics. However, a lot of them we actually now in the modern day of 2021, we actually know why, a deeper reason why those laws are the way they are. So it would be good, let's say, if you have law 1 and law 2, what we are now able to do is, for example, find out one law, maybe law 0, and with that law, I can actually reproduce the other two laws. So now we consider that as a more fundamental one. And you can go all the way up, right? And hopefully there's a law is basically an observed fact that seems to happen over and over again, and we don't know why, so we call it a law because it keeps repeating itself. And you do a lot of experiments and it's never violated. Some laws are violated after a lot of experiments. And then with modern technology, you realize the law only works in a specific limited capacity, limited case. When you push the limits, push the domain of validity, it's called, right? The domain of validity, you can break a law. But that doesn't mean it's useless. It just means it's useless out of that domain of validity. Within it, it's still useful because that's still true. Anyway, so yeah, so right throughout physics, you learn lots of different laws. So the idea is really to see if I can find a more common law that can actually explain all the other physical laws. In fact, one of the greatest achievements in theoretical physics is we're down to two, essentially. One law from quantum mechanics and one law from general relativity explains almost 99.999% of everything that happens in the universe. You can use those to predict exactly how the universe will end, and almost to the fraction of seconds of the beginning of the universe, right? So it's very powerful, very great development in theoretical physics over the past 50, 70 years. Not that long, we summarized it into these two things. If you're a fan of string theory, you'll try to find essentially what they call the theory of everything, right? They hope to have one law that can explain every other law. Anyway, conservation of energy is one of the law that people think it's the fundamental law that is the starting point of everything. But now we actually realize there's something deeper than that. But anyway, these are sort of the most modern developments in theoretical physics. Just in case you're curious, like one of my students used to ask, isn't everything in physics figured out since the 17th century? What's new? What's there to research? This is what there is. Anyway, so that's just, if you're curious, but that's to show you how fundamental the laws conservation of energy is. So in some sense, I cannot explain to you within this course without doing advanced theoretical physics why energy is always conserved, nor did people know why for over 200 years, but life goes on, right? So you treat that as a fundamental law, and this is the conservation of energy is probably one of the most fundamental laws, probably the most fundamental law you will learn throughout the Physics 3 series. In some sense that you will not learn anything that actually can explain the conservation of energy. But on the other hand, you might think that's a setback. But on the other hand, if you use the conservation of energy, you can predict almost everything else, okay, within the Physics 3 series. So it's that fundamental. Okay. Yeah, so we'll give you more examples as we go. So let me write this down. Fact number 1 is every object has different types and amount of energy throughout its motion, throughout the history of its motion. Okay, that's fact number 1. Fact number 2 is the total amount of energy stays constant throughout. So when you add up everything, you add up all the different types of energy it has and the different amount of energy it has, just more graphically, right? So let's say the object follows a projectile motion like this. Here it has a certain amount of energy, here it has a certain amount of energy. You add everything up. This is the Greek symbol sigma, of means adding or summation. Sum all the energy at this time at t equals 0. Sum all the energy at t equals to t1. Sum all the energy here, t1, t2, t3, t4, t5. You will get a number. This number does not change. Let's say this number is 13 joules. And it will stay 13 joules throughout. In the whole system, this is the whole idea. So the total amount of energy stays constant throughout its motion, throughout the history of its motion. And this has a name, and as I said, it's called the law of conservation of energy. So these two facts, I cannot explain to you why, but if you accept them, your life will be greatly benefited because we'll be able to explain almost every other phenomena to do with motion. And we'll see how that works, all right? Just to put this in a equation form, the law of conservation of energy, this in the box because it's so important, right? Well, this symbol, just for note-taking purpose, if you're curious, right? This symbol means implies. This symbol means equivalent to. If you have imply one way and this way, so it's like this implies this and this also implies this. So it means equivalent to. Some logic symbols borrowed from mathematicians. It's the sum of the energy. So it's a bit redundant. Sum of energy initial will equal to the sum of the energy in a final state. Okay, that's a mathematical way you can write it, or it's also, you can also write it as energy total initial and energy total final. It's also okay. Okay, all right. And this is the famous statement of energy can not be created or destroyed. It can only be transformed. All right. So another, this is also equivalent. You can say it as energy cannot be created or destroyed, only transformed. So it can go from one type of energy to another type because there's different types but you will throughout its lifetime, right, throughout the history, you wouldn't suddenly create new types of energy. You won't create new amount of energy. Total amount stays constant. So there's lots of ways to say the same thing, but that point number 2 is the law of conservation of energy. Okay, so this is the most important concept about this. And we will obviously now begs the question of what are the types of energy are there. So that's the next thing we'll look at and give a list of them. And once we have that, we'll be able to answer how do we use that? How do we use that to predict motions?